Every successful building you've ever been in, whether it's a massive skyscraper or just your local coffee shop, follows a hidden rule. It's a rule that kind of embraces imperfection in order to achieve perfection. And today, we're going to pull back the curtain and see what it is and why it's so incredibly important. So, what is this secret ingredient? What's the one thing that stands between a smoothly constructed building and, well, total expensive chaos on a job site? Let's dive in. The answer starts with an idea that might seem a little counterintuitive, a little backward at first. It's all about planning for things not to be perfect. Yeah, you heard that right. We're talking about planned wiggle room. And that wiggle room, it has a formal name, construction tolerance. Now, this isn't about somebody making a mistake. It's the exact opposite. It's a pre-approved, totally acceptable amount of deviation from a perfect measurement. It's basically imperfection by design. This slide really shows you why that's so critical. See, on paper, in the design, everything is perfect. Measurements are exact, angles are a perfect 90 degrees. It's all ideal. But in the real world, well, materials like steel and concrete expand and contract with the heat and cold, machines and people have limitations, and a construction site is not some sterile, controlled lab. Tolerances are what bridge this massive gap between the perfect blueprint and the physical, real-world build. So what happens when this planned wiggle room is ignored? Well, things get messy, and they get messy fast. We enter the world of clashes, where different parts of the building literally try to occupy the exact same space at the exact same time. And this is the first domino to fall. You ignore those acceptable variations, you push for some impossible level of perfection, and what you get is misalignment. A column isn't quite where the drawing said it would be, or a beam is a few millimeters off. It seems like such a small thing, but trust me, it's the start of a huge, huge problem. Because that tiny little misalignment, it doesn't exist in a vacuum. It creates a chain reaction, a cascade of chaos across the entire project. That one misaligned column means the beam that connects to it is also misaligned, which then affects the floor it's supposed to support, and on it goes. This is what we call a clash. And here you can see the real-world impact of that. The structural elements, the very skeleton of the building, they just don't line up. Your MEP systems, your ducts, your pipes, your wiring, they get blocked by beams that aren't where they're supposed to be. Windows literally don't fit into their frames. It is a cascading failure that quickly becomes a builder's absolute nightmare. All of this clashing and misalignment leads to one of the most dreaded words in the construction industry: rework. And rework is where projects go to die, both in terms of the budget and the schedule. I love this quote because it just frames the issues so perfectly. Rework isn't just about fixing something. It often involves actively demolishing work that's already been completed and paid for, just to start all over again. You're literally moving backwards, and it is expensive. This whole thing quickly becomes this vicious cycle, and you can see the painful steps right here. First, somebody discovers the clash. Immediately, as you see in step 2, all related work just grinds to a halt. Step 3 is the demolition. Only after all that destruction can you finally get to step 4, reordering materials, and then at last, rebuilding. It's just a massive waste of resources. And this chart just lays out the brutal consequences. Look at that first bar. Project costs don't just creep up a little, they skyrocket. And the second bar shows the schedule getting completely blown to pieces. These are not minor inconveniences. These are the two factors that define a project's success or failure. So if that's the chaos, what's the solution? How do we avoid this nightmare scenario? Well, we do it by shifting from being reactive to being preventive. We do it by building with precision. And that brings us to the solution: tolerance control. The key word here is proactive. This isn't about just hoping things fit. It's a dedicated system of planning for these variations from the very beginning, analyzing how all the pieces from different trades will interact, and then constantly measuring and checking, often with tools like 3D laser scanners, to make sure everything stays within those planned limits. This slide really highlights the two different worlds you can live in. The old way is reactive. You wait for the fire to start, and then you try to put it out. It's unpredictable, and it's expensive. The smart way is proactive. You plan for reality, you control the variables, and the result is a smooth, efficient, and predictable process. And all of this proactive planning and control leads to one ultimate benefit: better buildability. It's a simple word for a really powerful idea. It just means the project is fundamentally easier to build. The pieces fit, the trades can work without interruption, and the project just flows from start to finish. So let's recap the really crucial points here. First, tolerances are not mistakes. They are a necessary planned part of construction. Second, ignoring them creates a domino effect of clashes. Third, this leads to rework, which is a disaster for budgets and schedules. And finally, the solution is proactive tolerance control, and that is the key to achieving good buildability. And this brings us to one final crucial question. We've seen how planning for imperfection leads to a more precise, predictable outcome. So, if this proactive approach prevents so much chaos, why does it still get ignored on some projects? It's a critical question for the industry to really think about.